Hello guys, a very happy morning to every one of you. And guys, now we are just going to continue the industrial engineering. The next it means continuation, okay? And before thing, I just told about each and everything about what is the inventory and how the inventory is being managed and reason for maintaining inventory. It means each and everything and cost, unit cost, order cost, holding cost, and how the transportation, inspection, delay, rejection, delay cost, and holding cost, okay? So you can see holding cost comes under the category of power special requirement. It means cost of capital, insurance, taxes. You can see this all comes under the holding cost. Okay, you can see what tax also, because we hold means we can cover the insurance, we can cover the taxes also. For that also we need to give certain amount, and CCTV and security staff we have to just pay the money, and damage cost. Okay, you can see holding cost per unit per of time. Okay, you can see next one shortage cost. Shortage is loss of profit, loss of sales, and loss of opportunity, underutilization, rescheduling. Okay, these are the things that comes in the category of shortage and back order cost. Okay, so this one is a simple thing. Okay, so you can see inventory model is of two types. One is deterministic and probabilistic. Okay. Okay, deterministic model means demand is known and certain. Okay, you can see basic inventory model, Wilson and Harrison model. Okay, this one. Okay, I think so you can understand. So now just 5 minutes I'll just have a revision. So after this revision we can just start directly quantity. So this one, demand of year. Okay, let's assume for an item annual demand is 1200 per year. Just 1 second. Okay, this quantity is the demand per year. Okay, or you can just take a unit per month also, and n equal to number of order 3, and ordering cost, holding cost. This kind of things is depends. You can see when number of orders is ordering cost is less. Okay, number of orders and ordering cost is holding cost is okay. This one is total variable cost is ordering cost plus of holding cost. Okay, item cost means total cost, item cost plus total variable cost. So this is the peak, and this is this is demand, and this one which is you can see instantaneous replacement. Okay, so you can see number of orders, demand per year. Okay, demand per Q into of C naught. Okay, this is total ordering cost, this one. Okay, and this is holding cost is holding cost per unit per hour. Okay, so just we are just taking average Q divided by 2. Okay, this area, so 1/2 cycle area, this 1/2 Q into T divided by time. Okay, Q divided by 2. Okay, so action total carrying cost is CC into Q times the value, CC into Q divided by 2. Okay, total variable cost is total ordering cost plus total decrease total variable cost. Okay, so for this model it means what is the economic order quantity, root of 2d C naught of CC. Okay, 2d C naught of CC. Okay, suppose if this is the economic order quantity, this Q dash, so take this Q dash and go and place this in here. Okay, while we are just putting total variable cost minimum, it comes as root of 2d C naught of CC. Okay, okay, I think so I got the point. So you can see at the optimum condition, so you can see for this one optimum condition or this one optimum condition, the ordering cost and the holding cost are same. Total minimum value you can see both are same. So you can see total minimum cost equal to D into C plus root of 2D C naught of CC. Okay, ordering cost is this one. Okay, holding cost is this one, Q divided by 2 of CC. Okay, Y equal to M of. So what is the thing is, you can see cost which is quantity. So this is the ordering quantity, this is the holding cost. Okay, so holding cost and Q dash, so this is the minimum. Okay, so total minimum cost is this one and total variable cost is this one. Okay, so holding cost and ordering cost is the total variable cost, and this is holding cost. Okay, so observation from here you can see ordering cost is greater than holding cost. Okay, so sensitivity is just a simple thing. Okay, just 1/2 economic order means q dash will be q or simultaneously q will be q star. Okay, that's it. Okay, this is the basic thing. Okay, rt card 40 card I think that next one, inventory model with the shortage or pack order. Okay, so you can see this one, the shortage cost and the inventory cost and maximum shortage. So you can see this one IM, this one T1 and this one T2, this one is shortage. Okay, Q, you can see the basic thing is this one. Okay, Q divided by T, IM divided by T1 plus of SC divided by T2. Okay, and each and everything. So we can also write a demand equal to, you can see demand equal to IM of T1 or demand equal to shortage of T2. Because just a ratio, because okay, just it's a ratio. So this one, okay, Q equal to T1 plus T2 equal to, yeah, total active capacity equal to this one. So you can see, so they can has holding cost or the carrying cost to CC IM T1 divided by T2 2FT. Okay, like this is less holding cost, carrying cost, shortage cost, and just as directly. So total variable cost is this one. Okay, so you can see shortage cost alone QCC this one. Okay, so when it comes to the total economic order value, this is the total economic order value 2D C0 of CC, CC plus CS of CS. Okay, so I think so that the total minimum cost is this one. You can see this one. Okay, sometimes shortage is also so much important. Okay, so you can see production consumption model. I just told you production and production minus of this one. Okay, you can see I think so can answer. Okay, production country. This one is P, this one is P minus 1. This one is inventory model, this one is Q. Okay, this one is Q and this one is IM. Okay, this one is T1 and this one is T2 and this one is equivalent of T. Okay, Q divided by T1 equal to P. So okay, you can see Q equal to P of T1 and P. So this one is a simple thing, P minus T of T1 equal to IM. Okay, and IM equal to this entire thing is IM. Okay, IM is T of T2. Okay, the IM means inventory equal to Q, P minus D of P. Okay, next one setup cost, because we have to just set up cost for one setup. It means okay, so total variable cost to setup cost plus of holding cost. Okay, total variable cost is D0 C0 plus Q average of CC. Okay, so Q average equal to cycle time, cycle average by cycle time. Okay, so Q average equal to IM divided by 2. Okay, so you can see total variable cost is this one. Okay, and when you just put the in economic order quantity, the economic quantity comes 2D C0 this one. Okay, so total variable cost for minimum is this one. Okay, so you can see setup cost equal to holding cost. Each and every time the setup cost will be equal to, sometimes there it also same, here also same. Okay, you do this. Okay, so you can just see about this production consumption with the shortage, just the basics. Okay, so if this is the graph means, as I just told about, this is the production P and this is production minus of demand. Okay, P minus of D. So here like this loop, now we will take a shortage. Okay, okay, so again it will just increase, and this one is the production, but this one is the again shortage. You can see this is shortage. see for this one T1, sorry, this one T2, T3, this is T4, this is again T1. Okay, so you can see here timing is 4, so time T equal total length T1 plus T2 plus T3 plus of T4. Okay, I think so I can understand. So you can see this one T, so for time during where shortage are fulfilled and production is beginning. Okay, T2 is time during no shortage. Okay, so no to shortage, and T2 is built up, but T3 is time during only consumption. Okay, and T4 is time during where shortage are permitted. Okay, time T4 time during where shortage are permitted. So this one is IM. Okay, P minus T, I think so you have so this one is demand. Okay, actually Q average equal to cycle area divided by cycle time. So calculation every cycle area and divided by time. So I think so Q average we are getting this one. So you can see total variable cost is this one. Okay, so I think so it's not difficult, just basic mindset. Okay, for example total variable cost is, okay, D divided by Q or C naught. Okay, plus of holding cost is, okay, CC IM divided by 2 times of T, D2 plus of TG. Okay, you can see this is IM. Okay, here T2 and T3 there, IM T2 of T3. Okay, so CC divided by 2 of time total time plus next one, this one whole shortage cost, CS into shortage cost. This one is holding cost. Okay, it means for the shortage cost into shortage into divided by 2T. Okay, into T1 plus of T4. Okay, this one shortage time, so T1 plus of T4, that's it. Okay, so IM is P minus T divided by P of Q minus of S. Okay, so yes, it means what is the shortage cost is equal to Q CC plus CC plus of CS P minus T divided by P. Okay, this and DP. So if you just did the economic order quantity, you can see it means combination of the all thing. Okay, 2D C not C, P divided by P minus D, CS plus CS, CC plus CS to P CS. And total variable cost minimum is this one. Okay, entire thing you need to add, that's it. Okay, no need to confuse it. Okay, here setup cost is separate and holding cost and shortage cost is separate. Okay, I think so got the point. Economic order quantity will take up is discount. Okay, at economic order quantity total variable cost is minimum. Yes, total cost is total cost equal to direct cost plus DWC, this is an that economic order quantity guarantees minimum variable cost, but it does not guarantee minimum total. Okay, so yes, economic order quantity tells only about the minimum variable cost, but it does not tell about guarantee of minimum total cost. Generally the discount is given when we purchase large number of quantities. Okay, so you can see, for example, if quantity is Q, if they just bought less than 1000 means cost of the thing is 20 rupees, but if they bought greater than 1000 means they are giving 5% discount. Okay, so you can see the total cost decreases by 1 rupees. Okay, so larger number of quantity we get larger number of discount. Okay, discount is applied for all items. Discount is guarantee minimum item cost where COQ is a minimum variable cost. Okay, I think so you can answer. This is the total variable cost, this one is the total cost. Okay, it means direct cost plus of total variable cost. this one is a quantity, this one is a cost. Okay, so q dash, this one is total cost minimum. Okay, so I think so you can understand. So this is a variable cost. It's definitely the variable. Suppose you can see guys, direct cost this one, so 20 rupees, and direct cost is 90 rupees. You can see the gap simultaneously decreases because of the direct cost is varying. Okay, suppose for example the same thing, if direct cost is decreasing means you can see for 20 rupees the total variable cost is will be 100 rupees, means it is about 120. Okay, so we can order quantity of 100. Okay, 100 quantities. If total cost, it means direct cost decreases 90 rupees, total variable cost also total variable cost also might change. Okay, but ordering quantity will be definitely increased so much. Okay, in terms of economic category it's over 120. So 18 rupees means in economic order quantity, the quantity of order is 130, so it increase. Okay, so the graph will be like this. Okay, so you can see at the beginning the economic quantity will be 100. This one you can see the economic quantity is 120. You can see about this one economic quantity is 130. So depending on the economic order quantity, each and everything changes. Okay, q dash is root of 2d c naught of cc. Okay, okay, you can see when cc is given in rupees per unit per year, then economic quantity is same for different item cost. Okay, it means economic order quantity is independent of item cost. Okay, at that time. Okay, it means you can see this one. So in this you can see guys, economic item cost changes, this thing item cost changes, but economic order quantity at the base is same. Okay, so sorry, this one no. So just the ordering capacity. Okay, it means how to say, means if economic order quantity is a minimum 100 rupees, so this one it means for the first case I've already just told, direct cost is 20 rupees. Okay, the economic order quantity is 100 rupees. If the direct cost is 90 rupees, the economic order quantity is same. Okay, 100. If it is 18 rupees, the economic order quantity is same, 100. So but in the normal reality we can, for 19 rupees, since we have discounts, we can order so much. Okay, the normal quantity order is 120. Okay, here 18 rupees the quantity order is 130. Okay, here is 100 rupees. Okay, 100 rupees. So you can see depending on the economic order also each and everything changes. Okay, so economic order quantity just tells the same for all value given the direct cost price reduces. Okay, since you can see what is the formula, 2d c naught of cc. So you can see here direct cost doesn't come, so it is independent of direct cost. Okay, I think so got the point. You can see when cc is given in percentage of item cost, economic order quantity is different. Okay, okay, when cc means holding cost is given, you can see when cc is given in percentage of item cost, percentage of item cost. Okay, percentage of item cost is important, then economic order quantity is different for. Okay, I think so you can understand. So you can see here cc equal to I of c. Okay, equal to I equal to 10%. So cc is dependent on item cost. Okay, in this thing we just made it dependent. Okay, so that's why q dash is changing. Okay, so you can just see the price. You can see cc is 40 rupees per year. Okay, so you can see cost is 20 rupees, economic order is 1000. Okay, suppose suppose if they bought less than 800 rupees means you can see it is 20 rupees, more than 800 is 90 rupees. Okay, so you can see economic quantity is 1000. So in this you can see the cost is same. Okay, even though the cost changes, the economic order quantity doesn't changes. Okay, it will be same. Okay, just one second. Okay, you can see price breakup. Since the price is breaking 20 rupees to 20 rupees, 90 rupees, and coming to the minimum. Okay. So guys, whenever you can see, whenever you are adding, it means 800 means it's coming. You can see 20 rupees 800 coming here. But whenever you order 1000, we are just going into the phase of 90 rupees. So 90 is the minimum economic order quantity. Okay. Okay. So the economic order quantity itself tells you can order in a minimum quantity. It means in a maximum quantity of lower price. Okay. Next thing, go whenever the discount is before EOQ, we just go for EOQ quantity. So whenever the discount is before, generally EOQ will go. So in above cases we select 1000 items. Okay, we don't select the items, so it okay, definitely it will be problematic. So next thing you can see, if C is given, each and everything is given. You can see C is 20, C is 18, C is 16. Okay, you can see for C equal to 20, you can see economic order quantity is 900. But C equal to 18, you can see economic order is 930. For this you can see 950. Okay. So whenever you just take a minimum value, okay, you can see this one. These are things called price breakup. Okay. So total cost is this one, and only so I just understand. For above, check all the points above the discount is mentioned above the point. Okay. See, this whole problems come to I just explain to you. At the time you will have a clear cut understanding. Okay. So next one you can see lead time or reorder level. So okay, lead time is it is the time between placing one order and receiving the order. Okay, it means instantaneous replacement. Okay, placing and receiving the order. Okay, this one is the demand. Okay, this one is the lead time. This one is the total time. Okay, this one is the quantity. Okay, so generally before 1 or 2 days itself we just order. That is the thing called lead time here. Okay, okay, you can see. So D equal to Q divided by T. Okay, so Q equal to D of T. The next one, this demand also, demand equal to reorder level divided by lead time. Okay, so reorder level equal D into L of T, lead time. Okay, so you can see reorder level, it is the amount of inventory on hand on which an order is being placed. Okay, reorder level equal to demand into lead time. Okay, demand into lead time. So safety stock. Okay, generally we do consider safety stock. It is a minimum stock level of item below which the actual stock should not be allowed. Okay, to fall. It is called as buffer stock. Okay, just adding the extra. Okay, that's it. Also, we'll just take note. See, in deterministic model, demand rate is constant and no safety stock is required. Okay, S is equal to 0. If it is in deterministic model, safety stock is 0. Okay, but you can see in a probabilistic model, safety stock is not equal to 0. Okay, so here safety stock is required, so demand is varying. It is probability where demand is varying, but here the deterministic model, demand is constant. Okay, so you can see this one. This one is okay. Okay, this one okay. This one is a lead time. This one is a reorder level. So this one is the demand. This one is totally skew. Okay. So you can see this is a safety stock, okay. This is the entire time, okay. This is safety stock, okay. This one is reorder point. Okay, so you can see average intensity, average inventory is SS DOB. So average inventory, okay, SS plus Q to B2 equal to Q times average, okay. SS is constant and D is also varying, okay. So okay, SS is used in and it means emergency, okay. If safety stock is very high, holding cost is also so high, so it will be problematic condition, okay. So generally reorder level equal to safety stock plus of which one, lead time into demand, okay. Reorder level equal to safety stock plus lead time into our demand. Okay, so you can see for 4 days we had stock, but red line, you can see red line demand suddenly increases, okay. So 2 days only, suddenly we just order, okay. I think so you can understand. You can see this is probabilistic inventory one. You can see normal distribution curve probability density y equal to f of x. This is the area under curve gives the probability, okay. You can see f of x is 1 by root 2 pi sigma e minus 1 by 2 x minus of x bar of sigma of 2, okay. This is the entire thing. It's the function of this one, okay. So sigma is the standard deviation of demand during lead time and x is mean or average demand, x is particular demand, okay. I think these are the examples, okay. So x bar is 50 and these are the extra things, okay. So what is the standard deviation? So standard deviation is this one, okay. Sigma equal to root of epsilon x minus of x bar of square divided by n, okay. I think so can understand. So n is the number, okay. It means how much thing they have just given, okay. That's it, okay. So standard deviation we can calculate, and standard deviation shows how dispersed the data is in relation to the mean low standard deviation means, okay. Suppose if low standard deviation means you can see the data are clumps around the mean, okay. For example, this is the mean area means, so since the standard deviation is deviation, okay, deviation means standard deviation is low means this is the mean value 50 rupees means you can see standard deviation 51, this one like this, okay. If standard deviation is so much high, what will the thing will be negative, okay. Negative means you can see standard deviation will be here, so you can see the difference, the ranges is so much high, okay. You can see newspaper, actually no newspaper, I lost a couple, okay. Okay, so you can see this is a probability curve of one, so this is a probability of curve, okay. So you can see from average it deviates more and last year, so if standard deviation is other, so little problem, so sigma standard deviation is more for this, okay. So but for closer to range means you can see this is the sigma, okay, but you can see this is the average model, okay. This is an average thing, okay. This you can see standard deviation is so much varying, okay, but you can see for the standard deviation is such a low, okay. So when the curve gets closer, the standard deviation decreases, okay. Sigma shows the it means the spread of curve. Standard deviation does not tell for the particular data, it tells only for the group of data. So sigma 1 greater than sigma 2, you can see deviation is more for this one, sigma 2, okay. So x minus x bar is z equal to z, okay. So okay, you can see x minus x bar divided by sigma equal to z. So this is normal thing, you can see that is normal distribution problem parameter and sigma is the standard deviation, okay. So this is x is our value minus of which one, this x bar is our this one mean value, okay, divided by sigma standard deviation equal to z. So that is normal distribution parameter, okay. So whenever you just calculate this one f of x, the entire thing, you can see certain value will come, okay. So it means total area under curve minus sigma infinite y df equal to 1, so just equal to 1, and if in case z equal to 1 comes, you can see this one, okay. So this area is so much lesser, 0.68 to 0.26, okay? So lesser, okay? So you can see when z equal to 2, minus 2 and 2, when 2 comes, you can see the area it is 0.954. When z equal to minus 3 to 2, you can see minus 0.9973, okay? Suppose if we asked minus 3, and suppose this left hand which is z equal to 1 means you can take this one and to just start, okay? If my inventory, I have to stock 60 items, demand is 30 and so satisfy service level, okay? So I think so I can understand. So this one is, you can see x minus x bar divided by z, sigma equal to z, okay? So x minus of x bar equal to z of sigma. So x equal to x bar plus of z of sigma, okay? So generally this z of sigma is called as safety stock, okay? Next one, reorder level is, I just told you the same, okay? So x bar plus of z of sigma, okay? Safety stock, this one is the thing we are just adding, okay? Average demand per lead time, okay? For the lead time, sigma is the standard deviation, that is a normal distribution factor based on service level. See, you can see, suppose service stock is about this one, you can see when the demand is 70 or when you are keeping the stock at 70, the service level is 70.7. This is generally thing, okay? Stock out is 1 minus service level, this one stock out quantity, okay? So general demand and this is probability. So general multiply and just make the expected lead time demand is this one, okay? So next one is single order model, newspaper poi model or PVC good model. You can see cost of each newspaper is 2 rupees and selling price is 4 rupees and salvage price is 1 rupees. You can see 1 rupees you get profit, okay? Profit selling price minus cost price, this one. So let a newspaper boy purchase 50 paper, but on the day 55 was the demand, okay? You can see he was been lost by 1 rupees. So you can see on the next day the buy price 55, but he sells only 40. So the salvage 50. So loss per unit is 2 rupees, okay? Cost of overstocking, cost of carrying, okay? So generally for this critical ratio, you can see this one, CS divided by CC plus of CS, okay? Generally put in and get the value, okay? So that's it, okay? So guys, whenever we are just seeing the problem, we will have a good, it means understanding, okay? These are the problems which I want to tell you later, okay? So guys, then that's it for this today's video, and I'll just see you in the next video. Until then, take care, bye bye, have a good day.